Good morning or good afternoon. We are Presentation Group C from Tutorial Group 5. The first question will be presented by Lo Choi Yu.
This question is about in a certain clinic, the number of patients that are recommended to have laboratory tests after consultation follows the Poisson distribution with a mean of 2 per hour. In this question, we have to calculate the probability that during a randomly selected hour, at least 3 patients are recommended to have laboratory tests. First of all, we can let X be the number of patients per week. Refer to the question, at least 3 patients are recommended to have the test. So we can write the equation probability of X larger than or equal to 3. Afterwards, we can rewrite the equation into 1 minus probability of X smaller than or equal to 2. Next, we can change the equation into 1 minus probability of X equal to 0 plus probability X equal to 1 plus probability X equal to 2. Then, we can apply the Poisson distribution formula, which these symbols means the mean number of occurrences in the given interval. In this question, the mean is 2. Then we can conclude the equation into 1 minus Euler to the power of negative 2 multiplied 2 to the power of 0 over 0 factorial plus 2 to the power 1 over 1 factorial plus 2 squared over 2 factorial. After calculation, we can get the answer 0.3233, which is round off to 4 decimal places. Therefore, the answer of this question, the probability that during a randomly selected hour, at least 3 patients are recommended to have laboratory tests, is 0.3233.
Hello everyone, today I'm going to talk about the question Think 2 Q3B, and my name is Yu. Okay, let's start. The question is, the company is going to have an 80th anniversary celebration, and intends to invite guests to the birthday party in Hall of the Academy. Invitation cards will be sent to the selected guests, but experience indicates that 32% of those invited will come. Suppose that the company has sent out 100 invitations. If the hall can only accommodate 50 guests, what is the probability that it will be able to accommodate all the guests? So first, we let X equals the number of guests who will come to the party. Actually, it fulfills all the requirements of binomial distribution. 100 people, and the probability of each person who comes to the party is 0.32. So we need to find the probability that the hall will be able to accommodate all the guests who come. So which means we need to find out the probability that the number of guests who will come is under 50. Okay, since X follows the binomial distribution, probability that you have k guests to come to the party. So this equals to 100 choose k times 0.32 power k times 0.68 power 100 minus k. Then we have to calculate the probability that px less than or equal to 50, which equals px x equals to 0 and plus px equals to 1 and until p equals 50. In fact, we have too many terms to calculate, so it's very hard for us to calculate them one by one. We can choose an easier and faster way, which is approximate the binomial distribution by normal distribution. Since NP equals 32 greater than 5, NP plus 1 minus B equals 21.76, and this is also greater than 5. And also the p is belongs to 0.1 to 0.9. So x is approximately normal with the mean mu equals np and variance sigma square equals to np 1 minus p. So this is approximately normal with mu equals 32 and sigma square equals 21.76. So use the continuity correction, we can find out that px that less than 15 is the same as px less than or equal to 15.5. So we can continue the normal distribution calculations, and I put all of the process on the PowerPoint, so we can see that finally the answer is 0.99996. So it's a very delicate answer, and now we find the answer. Thank you very much. This is how I do this, how I figure out this question.
Hello everyone, I'm Sherman Man, and today I'm going to present question 3A1 in Mock 1. So the question is, the sales amount of invoices of a certain company is normally distributed with a mean of 15,000 and a standard deviation of 5,000. And the question of 3A1 is about find the probability that the sales amount of a randomly selected invoice is less than 11,000. And in this question, we are using the standard normal random variable. And denote Z, and let's imply that denote Z is the standard normal random variable. And the notation is Z is followed by the normal distribution with 0 as mean and 1 as the standard deviation. And so we can see that the amount of Z can be calculated by x minus mu, which is the mean, over sigma, which is the standard deviation. So back to the question, let x be the sales amount, and x will be the random variable, and this is followed by the normal distribution of 15,000 as the mean and 5,000 as the standard deviation. And the probability that x is less than 11,000 is equal to the probability that z is less than 11,000 minus 15,000 over 5,000. And so probability that x is less than 11,000 will be equal to 0.2119. And so therefore we can conclude that the probability that the sales amount of a randomly selected invoice is less than 11,000 is equal to 0.2119.
Hello, this is Zhang Yiting from Group 5. And today I need to talk about the first question in Mock 2, question 3A. Question is, the annual rate of return of a risky investment fund is normally distributed with a mean of 20% and a standard deviation of 40%. We need to know the probability that the annual rate of this investment fund between 5% and 50%. From the title, we know that this question is for the normal distribution, and the question gives us the mean is 0.2 and the standard deviation is 0.4.
So the first step is let x be the distribution of the annual rate of return. So we write this because x is followed by normal distribution. Then we have this equation. X is smaller than 0.5 and bigger than 0.05. And we also have this equation because this formula. So we know that z is between negative 0.375 and 0.75. After that, we can reference the nominal distribution table to know the number. But I guess most of you may have the question about this. Well, we need to know the space between these two data. But normally we calculate this space using this method. We use 1 to minus these two small space so we can know the space between these two data. But how we know the negative space? So we turn this data from negative to positive because these two spaces are equal. So we can use the 1 to minus these two spaces. In the end, we can calculate this data is 0.41955. Thank you for your watching.
So I will talk about the mock table 2, question 3a part 2. So first of all, we will let x be the distribution of the annual rate of returns by following the normal distribution. X follows of and the mean is 20 and variance is 40 squared. Second, we will let A be the annual rate of return, such that we will have Px greater than A equals to 0.05. And we can transform this equation to P set is greater than A minus 20 over 40 equals to 0.05. And by checking the normal table, we will see that A minus 20 over 40 is 1.645. A equals to 20 plus 1.645 times 40. And we'll have A equals to 85.8. As a result, so that the annual rate of return is 85.8%, such that the probability existing it is 0.05.
Hi, I'm Cecilia from Group 5. This is the question I'm going to solve. The number of a new model of high-definition television sold at an electric shop follows the Poisson distribution with mean rate of 10 per day. Calculate the probability that at most 1 day in the next 7 days, we have at most 7 televisions to be sold in a day. This is a quite complicated question. It is different from traditional Poisson distribution question. To simplify the calculation, I have divided it into two parts. In my opinion, we should calculate the yellow part firstly, and then calculate the green part by using the answer of yellow part. As for the calculation of yellow part, we need to let x be the number of television to be sold per day. And then using the formula of Poisson distribution, because the mean rate is 10, so the lambda is equal to 10. We want to calculate the probability of at most 7 television to be sold in a given day. So x should be less than or equal to 7. Plugging 1 to 7 into k respectively, and then add them up. After all, we can know the answer of the yellow part is 0.2202, correct to 4 significant figures. And if you want to use a more accurate answer, you can save the answer into your calculator. In the calculation of green part, we can use binomial distribution to calculate. Firstly, let y be the day which at most 7 television to be showed. In the formula of binomial distribution, n should be equal to 7 and p should be the answer of yellow part. Because we want to know the probability of at most 1 day in next 7 days, so y should be less than or equal to 1. We can plug 0 and 1 into k respectively, and then add them up. Finally, we can calculate the answer is 0.5219. Also accurate to 4 significant figures. This is my process of calculation. Thank you.
Hello, I'm Chen Zhenghua. I'm going to present our group's solution to mock exam 4, question 3 part C. The death rate of an infectious disease is 3% among those people who are infected. We are required to find the probability that among 100 randomly selected patients of this infectious disease, at most 5 of them will not be survived. In this case, the concept of binomial distribution can be applied because the situation possesses the properties of a binomial experiment. For example, only 2 possible outcomes in each trial, in this case, success, which can be denoted as the event that a patient will not survive, and failure, which can be denoted as the event that a patient will survive. Also, for all trials, the probability of success is constant at p, and the probability of failure is constant at 1 minus p, which is also called q. The value of p is between 0 and 1. Therefore, we can apply this type of probability distribution of the binomial random variable as the number of successes in n independent trials. Let us denote y as the number of patients who will not survive among 100 randomly selected patients. Then, y, the binomial random variable, follows the binomial distribution with parameters 100, the number of patients, and 0.03, the probability of success. Then the required probability can be expressed as the probability that y is smaller than or equal to 5. We can express it in terms of a summation notation. That is, by summing up the probabilities of the event that y equals to I at values of I equals to 0, 1, 2, 3, 4, and 5. We can further write it into more details like 100 Ci, which is a combination, 0.03, the probability of success to the power of I, the number of patients who will not survive, 1 minus 0.03, that is the probability of failure, to the power of 100 minus I, the number of patients who will survive. So we can substitute the values of I, 0, 1, 2, 3, 4, and 5 to express the summation of probabilities that 0 patient will not survive, 1 patient will not survive, and so on. Finally, we will get the numerical answer as 0.9192, correct to 4 decimal places. Therefore, the probability that at most 5 of the selected patients will not survive is 0.9192. Thank you.